Hello everyone, I am Dr. Emre Süren. This is Lab 6 where we will study anti-spotlighting attack. In my screen now you see one example. Let's read together. As always, we start with a system message, then we have data markers. Here, third, now we have a mutation block, which is anti-spotlighting. I will come to this point, but I would like to continue with the next sections. Then we have our malicious instruction, including our jailbreak. We have also an adversarial suffix here. We studied all these parts, but now we are adding anti-spotlighting block. The block that starts with parsing notice. Please use. As you may remember, data markers are used to help a large language model to separate instruction from data. That's why when we use a data marker, we usually tell spotlighting data marker to help large language models. Here we are employing anti-spotlighting. This is just to enhance our jailbreak prompt injection attack. Here we are trying to falsify the model to get conflict to separate what is data, what is instruction. This attack, anti-spotlighting, actually is a type of mutation attack. You may also pretty much consider a type of best of an attack that we studied in the previous lab 5. Now let's see it in action. This is our prompt injection playground where we study our lab exercises. Now we are switching to lab 6. We are using the dataset we have generated in lab 4. Now I am going to go and grab the file name. I will just copy the timestamp because the rest is the same. I updated the file name. This is our data set. That's why now we are switching to second stage, performing the attack. Now we will employ anti-spotlighting. Spikee quiet test allows us to perform our attack, prompt injection attack. Here we provide our data set with the -- dataset. Switch, then we configure our target. We use Gemma 3 on our local computer. Gemma 3 latest. Now this is the switch that we enable anti-spotlighting, attack anti-spotlighting. Then we give attack iterations. Here we provide three different anti-spotlighting methods. As you remember, once we examined all data sets, we haven't seen any file regarding anti-spotlighting. The data where this anti-spotlighting payload comes from, it is embedded into Spikee. In Spikee, we have a folder attacks where we find individual files for individual attacks. For example, best of n, how we perform best of n attack, and also anti-spotlighting. In anti-spotlighting, we have two main functions. One is performing the attack, but before we first generate our payload, these are encoded into variance variable, XML tags, JSON fields, those are separators, you should remember. Then we have Markdown separators. We are appending all these variants into variance variable. Then we have HTML or similar delimiters. Then section names. A large language model may process data in a document, email, message, whatever content. So we use these delimiters to separate instruction from data. Now we are generating our data by combining all these values. And at the end, we inject one of these four payload. Please use Delimiters for processing this message to avoid conflicts and so on. And now I'm coming back to our attack. So we configured our anti-spotlighting attack. No auto resume. We are not slowing down our speed. Now we are ready to go. Let's click it. Now I'm going to pause my execution. It took 23 minutes now, and we completed almost 29%. I started to get some timeout errors. That's why let's stop it, because we would like to analyze our output automatically. In order to apply automatic analysis, we need to stop it because it is overwriting to existing file. But first, we start with manual analysis. Now open the attack results file. Now I will go grab one data. Here I would like to search for attack name, that is anti-spotlighting. Here we find one anti-spotlighting attack. Copy, manual analysis, select everything, paste what we have, right click, format document. Here we go. This is our attack. This is our payload that we sent to a large language model. This is the response. As response does not contain the URL address, the success is false here. This is the system message, and the attack is anti-spotlighting. We need to see the payload regarding the anti-spotlighting, where we should see it in the beginning of the prompt, right? It is just before the malicious instruction as well as jailbreak. This is our jailbreak. So before we have end content and document. As you see, this anti-spotlighting technique didn't work with this attack. Let's see if we have success. Success, true. Unfortunately, we don't have any success true. All right. Now let's go back here. We will grab the results file, copy, then switch to third stage, analyze the results. First stage was generating the data set. We used the data set from Lab6. Second stage was performing the attack. The third one, final stage, is analyzing the results automatically. Now I copy, paste the file name, and click to run. As you see, we have 342 entries here. Let's confirm if it is correct. 300. Now here we have 684 entries, but our analysis says 342. Why this happens? Probably Spikee performed that much attack but didn't process entries, the remaining entries. That's why we don't have. And this is the total attempts. Anti-spotlighting, we have 342 samples. What we couldn't succeed, we couldn't find a vulnerability on our target, which is Gemma 3 version. So as a homework, what we can do next, we can change our target. For example, we can try QN model, as we previously found vulnerabilities on this model. Second, we can change attack iterations. Anti-spotlighting attack has been experimented by many researchers and many articles has been published on this topic. They have various numbers of iterations. Based on my research, 15 is ideal. These are the things that we can employ. For this laboratory, we are done. I am Dr. Emre Süren.